So from the other video, we looked at weighing method for volumetric analysis for calculating questions under volumetric analysis. And I explained to you that there are two ways to prepare standard solution, because when we are calculating for volumetric analysis or when we are doing volumetric analysis, what we use is a standard solution. And in my first video on this topic, I had explained that your standard solution is a solution of known concentration. So we've looked at the weighing method. We've solved questions under the weighing method where we said that N can be, which is number of moles, can be equal to concentration times volume. It can also be equal to mass over molar mass. So you can equate mass over molar mass to concentration times volume. And any other question that has to do with that formula, it's very effective in solving questions on that weighing method. Now we're going to be looking at the dilution method. Dilution is going to decrease concentration and it is going to increase volume. I hope you got this. So when we have a question on dilution, it means that there's a first concentration. After dilution, there is another concentration, and that is the first volume. But after dilution, there is another volume. All right, so let's look at this question. It said if 10 cm of a solution of a 2.0 mole per dm cube were diluted. From our first video, we had explained that whenever you see mole per dm cube, it represents concentration. Whenever you see cm cube or dm cube, it represents volume. Now, from the first video, we said that number of moles represent number of moles with N. We said it's equal to concentration times volume. That's CV, right? Now, where dilution happens, we are going to have the first concentration. We're also going to have the first volume. Now, we can equate this to the final concentration and then the final volume. Hence, for the dilution method, we're going to be using this formula, C1V1 equals to C2V2. So the first concentration, the first volume, the second concentration, the second volume. Now, the question says if 10 cm cube of a solution of 2.0 mole per dm cube. So we had 10 cm cube, we had this concentration for the 10 cm cube. However, when it was diluted with water, we got a concentration of 0.1. Now, how am I going to calculate this? I'm going to call this my V1. So V1 is equal to 10.0 cm cube. This is going to be my C1, 2.0 mole per dm cube. I have C2. This is going to be my C2. So C2 is equal to 0.100 mole per dm cube. Okay, and then the question is saying calculate A, the dilution factor, B, the final volume, and C. So the final volume is V2. This is what we are looking for B. Now we have dilution factor. What is dilution factor under this? How we calculate for dilution factor is that we are comparing either between the concentration or between the volumes. So the dilution factor or formula for dilution factor . So the formula of dilution factor is C1 over C2 or V2 over V1, right? So this is when you're looking for dilution factor. If you have the two concentration given to you, the initial and the final concentration, you're going to be using C1 over C2. If you have the two volume given to you, the initial volume and the final volume, you're going to be using V2 over V1. Now, not to mistake, this is simply saying C1 over C2 is equal to V2 over V1. If you cross multiply, you're going to have C1 V1, C2 V2, which is the first formula. C1 V1 equals to C2 V2, and that's just it. So this formula represents your dilution factor. So you can write it: initial concentration over final concentration, final volume over initial volume. This is how you calculate for dilution factor. So looking at this, we have our initial concentration, we have our final concentration, we have our initial volume, but we were not given our final volume. So for calculating dilution factor here, we are going to be using concentration, which is C1 over C2. So my C1 here is 2 and my C2 is 0.1. So dilution factor is going to be 2 divided by 0.1. This is simply saying this is the same thing as 20 divided by 1. So our dilution factor is 20. And because we use concentration, okay, you can have it as 20. So this is our dilution factor, 20. Now, the second question says find the final volume of the solution. So we have C1, we have B1, we have C2. We can use this formula to get our final volume. So I'm just going to clean this. So for our first answer, A is equal to 20. Now, we have C1 V1 equal to C2 V2. C1 is 2, V1 is 10, C2 is 0.1, V2 was not given. So I'm going to divide both sides by 0.1, 0.1. So this is 2 times 10 is 20 divided by 0.1. This is the same thing as saying 200 divided by 1. So V2 is equal to 200. The volume is in cm cube, so this also would be in cm cube. All right. So the last one is volume of distilled water added. Now the initial volume was 10 cm cube. You can see. However, the final volume or the volume of the final resulting solution, it's now 200. So what would be the amount of distilled water added? So from 10, you got 200. So to calculate the volume of distilled water added to the solution, we're going to subtract the initial volume from the final volume. So we're going to have 200 minus 10, and we're going to be having 190 cm cube. So 190 cm cube of distilled water was added to the solution to give this concentration. All right, so that is all about dilution method. So in volumetric analysis, I'm going to be cleaning this right now. So we have B as we have our final volume of the solution as 200, and then we have volume of distilled water added as 20. In calculating questions under volumetric analysis, so far we said we can use this formula, number of mole equal to concentration times volume. We also know that the number of mole can also be mass over molar mass. And then we can equate either of them. We can equate this to this. We also know that from this is CV, where we have 2 concentration and 2 volume, we can have C1 V1 equal to C2 V2, meaning that there is an initial concentration, there's an initial volume. After dilution, there's another concentration, and there's a new volume. And this is all we have so far from the weighing method and the dilution method. Do not forget that these two methods are the method used in preparing standard solution. So the number one method is the weighing method, and the second method is the dilution method. So the next thing we're going to be seeing now is the acid-base titration. Acid-base titration. So if you've ever seen a formula like this, CAVA over CBVB equal to NA over NB, this is the formula used for acid-base titration. Now, CA here, where CA is equal to concentration of acid, VA is volume of acid. Then you have CB as your concentration of base. And finally, you have your VB as volume of base. All right, so you have volume of base. Then you have Na, Nb, where N represents the number of mole of the acid, Nb represents the number of mole of the base. So Na is equal to number of mole of the acid, and Nb represents number of mole of the base. And this is it. Now, if we are given a question on that, you're definitely going to be given the concentration, You will be given the volume. You may be told to find concentration of base. In that case, you'll be given your volume of base. So you're going to be given at least three of those variables if you are told to look for anything here. So it's either you're looking for CA and you're given this three, or you're looking for VA and you're given this three, or you're looking for CB and you're given this three, or you are looking for VB and you're given this three. So you are definitely going to be given at least three parameters from here, and you'll be told to find one. Now for this and this number of mole of acid and number of mole of base is usually gotten from the equation. So they could tell you that HCl is reacting with sodium hydroxide, um, and then they're going to ask you a question. Now, this you get it from the equation. However, for you to be able to get this correctly, you have to balance the equation. If the equation is not balanced, this will be wrong. And if this is wrong, your whole question is going to be wrong. Now, but then there is a little trick. So I'm just going to clean this. So if I'm an exam student and I'm trying to save time, because for your exams, you need to be accurate and you need to be fast. Speed and accuracy is the reason why you're going to score very high. Now, if I'm in an exam hall, because I'm trying to be fast, I will not want to balance an equation when I may not need to be balancing the equation, but would still be able to know my NA and NB. There's something called basicity. Now, what's basicity? In acid base, we're going to talk about that extensively. However, for this topic, we're just going to give a brief explanation of this. Basicity is the number of replaceable hydrogen ion in an acid, right? So, for every strong acid, we have monobasic acid, we have dibasic acid, and we have tribasic acid. So monobasic acid, we have acids like HCl. In fact, generally, hydrogen with any halogen, HBr, they are all monobasic acids. We have HNO3. This is a monobasic acid. Now for our dibasic acid, we have acids like H2SO4, H2CO3. These are dibasic acids. Now this is monobasic because it has only one replaceable hydrogen ion. This has one, just one. This is dibasic because it has two replaceable hydrogen ion. Two replaceable hydrogen ion. Now for your tribasic acid, you have something like, you have this. This has three replaceable hydrogen ion. So if the question is asking you, HCl is reacting with a base, and make sure it's a base and not a salt. What do I mean? Make sure it's sodium hydroxide and not sodium trioxocarbonate. Please, once it's a salt like this, look, balance the equation for you to be on the safe side. But what is a base? A strong base like this. What strong base? An example of strong base that you encounter: potassium hydroxide, sodium hydroxide. These are the two strongest bases we have. All right. So if you're given this or this, then you're on the safe side. So if you're given an acid and you're given either of this, potassium hydroxide, or you're given sodium hydroxide, then you're on a very safe side. And a lot of times, you'll be given either of the sodium hydroxide or your potassium hydroxide. So what do? If I've been given a monobasic acid reacting with a strong base, one of the laws of basicity states that a strong or a monobasic acid is going to react with 1 mole of a strong base, meaning that 1 mole of this is going to react with 1 mole of a strong base. So for my Na, I don't need to balance any equation. I will just know that number of mole of acid is 1 and the number of mole of base is 1, because monobasic acids, 1 mole of a monobasic acid would react with 1 mole of a strong base. Now, if I'm given a dibasic acid such as H2SO4, I will know that my number of acid is 1, because Over here again, it states that 1 mole of a dibasic acid is going to react with 2 moles of a strong base. So I'm going to have 1 mole of this reacting with 2 moles of a strong base. Then for my tribasic acid, I'm going to have that 1 mole of a tribasic acid will react with 3 moles of a strong base. So what is the tribasic acid? My number of mole of acid is 1, but my number of mole of base is 3. Once is a diabasic acid, my number of mole of acid is 1, my number of mole of base is 2. Once is a monobasic acid, my number of mole of acid is 1, my number of mole of base is 1. So bear in mind, HNO3, HCl, HBr, HI, hydrogen halide, they are all under your monobasic acids, HNO3. This H2SO4, H2CO3, dibasic, H3. So we are calculating it based on the number of replaceable hydrogen ion. So you can see here it's 1, here it's 2, here it's 3. I hope you got this. So having known this, let's see a question on the acid-base titration quickly.